Globus-enabled systems. So what's Globus? It's a secure, reliable service. More than 150,000 registered users rely on Globus. More than 150,000 registered users rely on Globus. So what's Globus? It's a secure, reliable service. With the Globus platform, you can easily incorporate robust capabilities. And if the data is sensitive, no problem. Globus can be used to manage protected data. With Globus, you can easily share your data without having to move it or copy it. With Globus, subscribers can easily move and share. And if you have any more questions about Globus, visit Globus. More than 150,000 registered users rely on Globus. More than 150,000 registered users rely on Globus. If this sounds familiar, you're not alone. Many thousands face the same challenges every day in solving with Globus. So what's Globus? So what's Globus? It's a secure, reliable service. With the Globus platform, you can easily incorporate robust capabilities. More than 150,000 registered users rely on Globus. More than 150,000 registered users rely on Globus. And if the data is sensitive, no problem. Globus can be used to manage protected data. With Globus, you can easily share your data without having to move it or copy it. With Globus, subscribers can easily move and share. And if you have any more questions about Globus, visit Globus. So how can you get started using Globus? Anyone can use Globus right now for free to transfer files between Globus-enabled systems. So what's Globus? It's a secure, reliable service. More than 150,000 registered users rely on Globus. More than 150,000 registered users rely on Globus. So what's Globus? It's a secure, reliable service. With the Globus platform, you can easily incorporate robust capabilities. And if the data is sensitive, no problem. Globus can be used to manage protected data. With Globus, you can easily share your data without having to move it or copy it. With Globus, subscribers can easily move and share. And if you have any more questions about Globus, visit Globus. More than 150,000 registered users rely on Globus. More than 150,000 registered users rely on Globus.
Yo. What fresh hell is this? Check, 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 check. You can only hear me once, but I can hear myself on a delay. Check, check, check. Check, check, check. Hey, Ferris. Give me just a second, folks. What up, Vera? Yes, this is Ferris. Hey, what up, Open Set? I don't even know where it's coming from. Oh, is it that? Am I that? Check, 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 check. Yeah, there we go. I had my own stream open in the background. Oh. Oh, welcome, everyone. OBS just updated yesterday and everything was fine, so I automatically assumed that there was a problem with OBS today, because that's how that works. All right. So today we're going to be talking with Corey Campbell. We spoke with them about 5.5 months ago regarding AI and biochemistry. And because of how quickly everything's been moving, we wanted to talk with them again and see if, what kind of updates they had. All right. All right, Corey will be with us in a minute. And there should be no ads after the pre-roll. If you get an ad please let me know, because I'll have to figure out something else. But I don't run ads on this stream at all. If I could have 0 ads whatsoever, I would absolutely do that. This is not a financial endeavor for me. I'm just that sub goal. That sub goal is just like to so that I get the payout, right? So that the money comes out of Twitch's account and comes in here. Ferris, you cannot be on the desk. You either get in the lap or get up here. Pick one. Yeah, there are there are rules regarding what I can say around that, Vera. So in Discord, either mine or Paradigms, um, I might be able to give you anything, but here I cannot. Yes, Ferris. I don't even know how old Ferris is. I want to say that Ferris is 16. Because I'm pretty sure that I got Ferris before my son was born. But Ferris is love. Ferris just wants to be near me when I'm in the space. So. Thank you. All right, Corey is in. Let's switch scenes. Join the thing. What up, little Donnie Fun? Ooh. Hello? Yep. Give me a second to make. Every time I come in here, I gotta adjust something, but it's fine as long as it works. All right, that looks good. Ladies and gentlemen, this is Corey Campbell. Corey Campbell, why don't you let people who don't know who you are, who you are? Hold on 1 second. For some reason, let me try this. Okay, go ahead and say something.
Testing. Should I start over?
I think so. I'm just waiting for a confirmation from Little Donnie Fun that chat can hear you. We
Gotcha.
Good. Go ahead. Thank you, sir.
Well, so even though you heard it, I think the chat should thank you for inviting me on. Super appreciated and super grateful. But yeah, I'm Corey Campbell. I'm a scientist, PhD candidate in biochemistry. You can find me on Twitch. I cover science and news and research and some politics as well every once in a while. But yeah, you can find me on Twitch, Corey Campbell 84, and Instagram, it's Corey Campbell, and I guess technically Instagram as well. Also, it's Corey Campbell, and I think that's about it.
And I caught a recent episode of yours, and you were speaking with another Twitch streamer regarding
Yes.
experimentation. You want to give me a brief summary of what that was about?
Absolutely. So it was I was on Saturday, this past Saturday. I was doing a collaboration stream with Neuralicia, fellow Twitch streamer. They're, I think, fairly new to the space. Neuralicia, they're also pursuing their PhD, but they're pursuing their PhD in neuroscience. And we pretty much on Saturday we covered essentially a neuroscience paper, or rather it overlaps. It's largely neuroscience, but there's a little bit of like biochemistry and biology. And so it's kind of like just pretty much like doing a deep dive onto a paper, a neuroscience paper, and kind of like giving our own perspectives, and me also trying to understand it better from the neuroscience perspective, or maybe the neuroscience / psychology perspective, as opposed to just my own perspective, just like the biology and biochemistry aspect.
Yeah, and it was really interesting. You had good chemistry, and I think you both did an excellent job. One of the things I like about your content is that you're able, because you work in like the science of big names, right? Like where things have like really complicated names, really complicated names of either the things that you're working with or the we got a raid. Real quick, welcome Raiders. This is
Yeah, go for it.
Corey Campbell. We're having a conversation with them today regarding AI and biochemistry. Welcome in, and shout out Paradigm, and I always appreciate you, homie. Make sure you click the link to be welcomed in. Interesting that there wasn't an alert, but as I said, OBS just updated. Anyways, as I was saying, you work in the science of big words, and it can be really difficult to translate that information to the lay audience. And I think that is one of the places that you have, that particular skill, is that you can take this complicated information and present it in a way that's easily digestible.
So I super appreciate that because one of my ultimate end goals, or just ultimate goals, is to hopefully translate some science and make it more accessible. Since I think one of the issues, there are many issues in science, but I think one of them is like, it's very often, not only behind closed doors in, our quote unquote ivory towers, but also in terms of like the actual research and how it's communicated. I think it's not done very well. Now, whether I do it well or not, obviously, I can't say, but I appreciate the feedback and I try my best. Where it's like, I think science should be more accessible, and I think there should be, ideally, like more science communicators that are able to break it down. And I hope I at least play a part in that, but that's to be seen.
Mm-hmm. Yeah, and that I definitely agree. I think that one of the things that happened with the COVID pandemic is that people were being told like what to do, but not why, and none of the people wanted to communicate that in a really effective way. I think that we need, like, I know Dr. Neuro. Do you know Dr. Neuro?
Absolutely, yes.
Okay, so Dr. Neuro is a good communicator and works for the CDC. We need more of that. You know what I mean?
Yeah, absolutely. And I think you kind of, in my opinion, hit the nail on the head. I think generally speaking, I think it's important that people understand the why. This is more or less my approach to teaching as well. In terms of when I encounter students, or even just teaching actual lab skills, in the lab of how to carry out an experiment. Very often, you're following a protocol. You can think of it like a recipe. It pretty much is a recipe, just as baking a cake. And you can follow the directions, but generally speaking, it's better. It's largely better to understand why you're carrying out each step, as each step in baking a cake. Not that I'm a baker, but but each step in pretty much any recipe that you carry out, like the order matters, and why you're doing what you're doing. Like there is a rationale and thought process behind it, and the same thing holds true in science, and also just I think in our behavior. I think we just understand things, or rather, I think we just operate better when we understand the why, as opposed to just like, here's the marching orders. Well, there's usually some reasons, hopefully some good reasons, as to why those marching orders are there.
Yeah, and that's 100% the case. Like in any, I've had jobs where I've been in like a management position, and I've always found that the people who were working under me performed better when they knew, not only what to do but why to do it and everything else. Because then they feel more informed as opposed to I'm just doing some arbitrary crap and it doesn't matter. And I think that when you're talking about safety protocols regarding a pandemic, that's a very important factor to bring in. So I appreciate people like yourself, Dr. Neuro, Homozygote, and Dr. N. Any of you who are out here, and Neuralicia, who I just started following but haven't been able to catch a stream. Any of you who like are really in the science community, who take the time to to get this to us so that we can understand it better, which is what I try to do, but I'm not like a PhD in AI. I just happen to understand it. You know what I mean?
Yeah, and also again to your point, and I guess to maybe reinforce it, like the students, in my experience, I've taught quite a few students, both in tutoring aspect and in the courses that I've been a teaching assistant for. Like the students that typically perform like the best are the ones that they want to understand the concepts behind it. It's the students that come to me saying, "Hey, I want to understand this," as opposed to the student that says, "Hey, give me the answer to this problem." Because they when you approach it from understanding and like the concepts behind it, I think it's way more empowering, and I think you just like get more from it for sure.
Absolutely. So when last we spoke, you were using AlphaFold as a tool to get better results, faster results from protein folding and protein discovery.
Exactly right.
And what does it look like now?
So well, great memory, because I barely remembered. But yeah, so that was this is as you're probably you are certainly way more informed on the AI space than I am. But like AlphaFold, or rather specifically AlphaFold 2, has been like a big step, and that's sort of what we covered last time that we spoke. And as I think you probably like highlighted before, like things are really speeding up or ramping up like exponentially. Even with things like I don't follow it closely, but it seems like even just like ChatGPT, just like quick new iterations being released, and then also now multiple companies competing to like just faster and faster and exponential growth. So there totally have been maybe not as exponential progress like ChatGPT, but there have been some pretty large steps or maybe leaps that have occurred since the last time we spoke, just like 5 or 6 months ago, where the big step, or one of the big steps along like the pathway to AlphaFold 2, it's like as you said, it appears to be pretty so far quite accurate, not 100%, and doesn't cover every protein in existence, but it seems to make really good, accurate predictions compared to what we've used in the past. As in, like, given this new tool and comparing to all the other tools that we have tried to use to solve protein structures, or not solve, predict protein structures, this one just like far surpasses anything that we have used so far, and it appears to have pretty much taken a big step in a short amount of time. And so in that time, there have been further developments, not only in AlphaFold 2, but in sort of, you might be able to also teach me some things, because what is AI? As in, like, I come across papers of like, well, they're using machine learning. Is machine learning under the umbrella of AI? And then I come across other papers that say they're using deep learning. And is that something else? As in, I don't actually know the full difference between deep learning, machine learning. Are these separate from AI? But there have been, if deep learning and machine learning are under the umbrella of AI, then there totally have been some developments in that respect. As in, so AlphaFold, in terms of predicting protein structures, again, big step. But the structure of a protein, there are many aspects to protein structure that are not exclusively tied to the amino acid sequence. Or rather, there's like other ingredients. So maybe a little bit of, I don't expect everyone out there, or I don't expect really anyone, unless they're in the field, to really understand what proteins are. But the example that I like to use, and I probably used this exact same example last time, proteins, you can think of them like they're structures, they're macromolecular structures, and they are composed of amino acids. And I think of the amino acids like Lego blocks. There's 20 amino acids, and so you have like 20 Lego blocks, and they can be assembled in sequence and can adopt pretty much infinite 3D conformations. You can kind of think of each protein as like a snowflake. Each one is pretty unique, and they just span the tiny snowflakes, and you can have like giant macromolecular, kind of like almost like miniature machines at an atomic level. But there's more to proteins than just the amino acid sequence. The best example that I can come up with is, let's say, hemoglobin in your blood. So your blood carries oxygen, and like the protein that is responsible for carrying oxygen in your blood is hemoglobin. And I think most people are familiar with, let's say, anemia, or specifically iron deficiency anemia. So it's not the hemoglobin alone, the protein alone, that carries the oxygen in your blood. It's actually the iron that is bound or attached to the hemoglobin that actually carries the oxygen. As in, you have your protein structure, the hemoglobin, which is a large, fairly large structure, but embedded in it is iron. And it's the important element, or what gives the ability of hemoglobin to carry oxygen, is the iron. And that's why if you're deficient in iron, one of the common symptoms of anemia is lack of energy or being really fatigued, because you have a reduced ability to carry oxygen in your blood, and that affects your energy levels downstream. All that to say, when it comes, how is that relevant to AlphaFold? So AlphaFold, when we last spoke, as I sort of attempted to highlight, whether successfully or not, is that it appears to be pretty good, or a big step in being able to predict the 3D structures of proteins. But since there are other elements that give the function of a protein, as in the example of hemoglobin, it's not just the protein structure, but also iron as well. As in, it needs iron to actually have its full function of carrying oxygen. So now, previous versions, or let's say the first iterations of AlphaFold, it's it appears to be pretty good at predicting the structure. But you can kind of think of it as it predicts the structure of hemoglobin, but it doesn't predict that there's iron there. But the iron is critical for its function.
Right.
And so it's if we're trying to predict a protein and trying to predict its function, we need information like that, as in, this, as in the example of hemoglobin, this protein has iron, or some other proteins have other metals like magnesium, calcium, etc., etc. And there's a whole bunch of other things as well. Actually, another example that I can sort of extract from one of my own streams is I covered specifically a paper about an ice binding protein, as in, or I guess to be more specific, an antifreeze protein, as in this protein found in nature is able to basically act as antifreeze, as in it prevents or breaks down ice.
Okay.
Now, one might ask the question as to why would you find this in nature? Well, it was isolated from an organism, I think a fish, that pretty much lives or swims in basically close to freezing water.
Mm-hmm.
And so if you don't want the fish to freeze, or some microorganisms have the antifreeze protein, if they don't want to be frozen, and so they make this antifreeze protein, as in it binds ice and it's able to basically break it down or prevent the formation of ice. And yeah, go ahead.
That's like, how familiar are you with like cryo, with people freezing themselves, preserving their heads, or like in long distance space flight or any of that kind of stuff?
I'm not super familiar. I'm only familiar in the sense of like I know, or rather, there's, let's say, researchers working to pretty much fully understand what these antifreeze proteins are doing to hopefully implement it in for uses like that. As in, what I can say with confidence is like I believe some antifreeze proteins are used in, let's say, food packaging for food packaging uses. As in, like, since the fact that they are able to pretty much prevent the formation of ice, we can just like have these antifreeze proteins, or maybe more specifically engineered antifreeze proteins that are just like part of food packaging that are better than anything else. Or another example, I believe it's also trying to be adapted of, let's say, I don't know the climate that you live in, but I live in Quebec, and or Canada, we have fairly harsh winters.
Mm-hmm.
And in winter, we just like blanket everything with either like salt or sand to pretty much melt the ice or prevent the formation of ice. But there are issues actually with using salt, where it's like not only do you have to like buy a bunch of salt and disperse it, but as you like dump salt, that salt eventually has to go somewhere, and it actually appears to be kind of like pretty much flows into our water sources and results in potentially deleterious effects. So I believe potential alternatives that's being looked at is like, we might be able to use these antifreeze proteins instead of something like salt. That they're proteins, so they should be biodegradable, and they should not, let's say, and if in fact they're engineered, we can basically custom make them to maybe even be better, maybe even, let's say, more biodegradable, more effective, etc., and that's actually another thing that has been a development in the AI space when it comes to protein prediction or protein structure or protein engineering. But to sort of like wrap it all together, of how this antifreeze protein is relevant when it comes to AlphaFold and predicting protein structure. So yeah, this antifreeze protein, when I brought it up on stream and the structure, on its surface, let's say to, I guess, just about any biochemist that's familiar with protein structure, it doesn't, let's say, stand out as ultra special. That's actually a very pretty simple structure. It's just like a very helical. It's kind of like it's a 4 helix bundle. It's just like, you can think of it as just like 4 helixes, and they're stacked together.
Right, like two DNAs stacked.
Yeah,
right on
that's exactly right. It just happens to be like 4 strands, basically. But what was noteworthy when they actually solved the structure of this protein, and they did this through the traditional methods. This was not solved through AlphaFold. It was done through, actually experimental methods of like, this is the actual structure. We're not predicting it. We're experimentally determining it.
Mm-hmm.
But what was noteworthy about this protein is that it was actually, so generally speaking, as mentioned, proteins are like fairly large macromolecular structures. And so they have like an outside surface, and there's actually like, pretty much you can think of it as like a core, like the core of the earth kind of thing. As in, like, they're so large that they have a surface, and they have a core that's largely inaccessible. And typically speaking, the core of a protein is what we call hydrophobic, or rather afraid of water, as in you typically don't find water in the core of a protein. And there's multiple reasons for that. But every once in a while, like, yes, you'll find maybe like a couple of water molecules, but generally speaking, the core of a protein, you just don't find water. It's hydrophobic. But this antifreeze protein, when they solved the structure, they were surprised to see that like the core of it. So it's a 4-helix bundle. It's literally just like a 4-helix. I wish I had a better way, but it's just like you can think of it as 4 cylinders.
You understand what DNA looks like, and if you had 2 DNAs that were like wrapped up in each other, forming that kind of. I think there's a science fiction movie that actually uses that as the premise. The alien race has 4 as opposed to the 2 that we have.
But basically, to the surprise, and this was actually at the time a high impact publication. It was published in Science, which is like one of the top tier journals in science, if not the top tier. But yeah, to the surprise of, let's say, the researchers, like the core of this protein was filled with water. Not just like 1 or 2 water molecules, which you would find in nature, but just like an abundance of water. And not only was there an abundance of water, the water molecules appeared to actually be critical to its function, as in like it needed this water in the core to actually be able to carry out its ice binding properties or function. And so how does that relate to AlphaFold? Or rather in terms of protein prediction? Well, given the fact that this was noteworthy, finding this protein that is pretty much filled with water inside its core, and a bunch of water, and the water molecules appear to be specifically oriented. They didn't appear to be just like randomly scattered. It appeared to be like, well, it was a highly ordered network of water molecules. So, how this relates to AlphaFold is that, like, given the fact that it was actually the non-protein aspect of this antifreeze protein that was critical to its function. Similar to like the hemoglobin example of like this iron is critical to the function of hemoglobin. Let's say past iterations, or rather it was an open question of like, could AlphaFold, if I just give it the amino acid sequence of this antifreeze protein, would it be able to predict that like it has a giant network of water molecules inside of its core? And like, again, this is critical to its function, as in like, if it's not able to predict this aspect, well then it's kind of like, who cares? Because like this protein needs that network of water molecules inside its core to carry out its function.
Right, it's going to limit its efficacy regarding discovering the full functionality of how these things work.
Exactly right. Where at the end of the day, we're trying to solve protein structures to determine their function. Because that is pretty much, for lack of a better term, that's kind of like the dogma in whatever biochemistry or protein science is like the structure of a protein determines its function. And so when generally speaking, when we know its function, we can either like engineer it or like we know what it's doing at, in a biological process. There's multiple things we can extract from its function. But like, yeah, as you correctly point out, if AlphaFold is not able to predict this aspect, then it's like, well, it's not all that useful, or maybe not as useful as it could be.
Right.
And so there have been some papers published fairly recently, kind of like testing this out, as in like, basically, can it predict, using the hemoglobin example, that this protein would have, let's say, an iron bound to it, or a magnesium, or what we would call an iron-sulfur cluster. Basically, can it predict kind of like the non-amino acid stuff that are also critical to its function? And other things that have, let's say, been developed, or let's say are in the process of being developed, is like, I don't know if it's specifically AlphaFold. It might be some other, this might be in this sort of like machine learning or deep learning aspect. But also, can we predict what either these proteins bind to? In the case of like the antifreeze protein, it binds to ice. or can it predict what other proteins this protein binds to? As in, like proteins, they bind to other proteins, and that's actually critical for biological processes. So those have been some of the developments that like I can get into more if you want, but pretty much trying to like push the limits of like, okay, outside of outside of the amino acid sequence, or rather,
Oh, Corey, you froze. I'm still good. Am I still good? Yeah. Okay. Do. We'll give Corey a second. See if he comes back. What up, Orange Hue? Welcome. So, while we're waiting for Corey, the reason that I asked, what up, Zero, about the cryo aspect of it, when you have, um, when you freeze a person, right, or a lot of things, what you end up having happen is that um, ice crystals form within the tiniest capillaries and they shred the capillaries. So when you unthaw people, you're basically left with a certain amount of mush, right? And this is not useful, right? Like if people turn to mush once you unfreeze them, then this is not a useful technology. So if we were able to use this protein to prevent the formation of those ice crystals, that would be a huge advantage. We are Zero. We are talking about AI as it relates to biochemistry. Um, Corey did indicate that there might be some issues with their connection. Um, so we are just playing it by ear and going easy and like that. If this is your both, I mean, well, what I talk about on this channel is both. Um, as far as what we're talking about with Corey, it is really current use. You know, like what we talked back about 5.5 months ago, and thank you. About 5.5 months ago, and they were using AlphaFold, to assist in predicting proteins. There was a huge increase in the amount of predictions that were happening. It was a great advancement, and now there's AlphaFold 2. So I'd like to give people who are working practically with these things the opportunity to educate all of us on what exactly that looks like and what they're doing. Yeah, Zero. I'm looking to do more with my YouTube channel once we get to summertime. Um, and I can have some additional time to edit down some of the videos. I've saved everything. I have all the VODs saved as highlights, and they just need to be like edited down and like an intro and an outro to each episode. I have the one with Homozygote, which is just basically I just drop the interview on there, kind of as a placeholder. Um, like, I would definitely be interested in talking about that around AI because I feel that there are aspects of these automated assistants and AI, um, pieces of software that have the capacity to, you know, to assist people in that regard. Like to do the things that they might not be able to do, to interact with the things that they might not be able to interact with. And I'm all about like, the more people who can do something, the better off we are as a species, is because you're expanding the talent pool. You might have someone who has, like the capacity to think about things in a particular way, which is going to lead to some great insight, but they're prevented for some reason from accessing the tools that they need in order to, give us all that benefit. And so I would want to see more of that. So if you want to think about that, and we could definitely have another conversation. And Corey is back.
Sorry about that.
No problem.
If it happens again, I'm just going to use my wireless hotspot on my phone so that I don't run into this issue. But it's super frustrating. I should be getting a new modem soon. That hopefully solves this issue.
So real quick, so we were talking about how whether or not AlphaFold could predict these additional molecules that are integral to the performance of the protein to do its job, basically. And
Exactly.
is there a determination on that?
So I'll actually put it in the chat. Where
And we were so close, Corey. We were so close. Okay. Yeah. So like Dankness is saying here, that's why the frogs have those ice nucleating proteins, because when they hibernate in the winter, they just freeze and their hearts stop beating. But if the cells freeze, it bursts them, and that lets the toothpaste out. 100%. That is, you need to be able to cool down the thing to the point where it no longer like functions, but like doesn't freeze with the little ice crystal formation. Yeah, but some chump from Western New York can just sit here and chill on the internet. But the People's Republic of Quebec can't provide my man with good internet. What's happening here? So, if this is your first time here, I talk about AI Monday and Wednesday every week. There's a special episode because if I do have an interview with someone, I try to accommodate them to the best of my ability. And then Fridays. Well, you need to share some of that with Corey. On Fridays, I talk with with Arun about Indian and South Asian politics. I love to talk to people. If you work with AI in any capacity and you would like to come on and talk about what that looks like in your world, I would be more than happy to have a chat with you and see if we can't work something out.
okay, I should be back.
He's back. Oop, I leaked our DMs. Oh, kind of back. So yeah, that's where I'm at. So make sure you hit that follow button. if you got it like that and you want to subscribe, you get some fun, cool emotes. I support artists in creating a bunch of my emotes. And, you know, any money that I get through streaming comes back into the stream in some capacity. So there are things that I would like to get that could improve the experience. And you can help fund that with your subscription. This will be the only time I talk about subs on this. I do it like once per stream, and that's it. And, you know, don't do the hype trains and scam trains and come for your wallet and stress you out. I would rather you have the information and have the knowledge than me make some, extra money. It's just not like that. The knowledge needs to be freed. All right. Oh. Is that you, Santa Claus?
I'm here. Can you hear me?
I can.
Can you see me?
I can see you.
Okay. I think this is whatever can go wrong will go wrong.
Yeah. No. People think streaming is easy, right? I just turn on the camera and then I just talk and then everything works. It's like, no. This is like Star Wars and Chewbacca's running around the back of the Millennium Falcon just strapping stuff together. That's what streaming is like.
But so you're able to see and hear me loud and clear. Okay.
Yeah.
So yeah, I'm on using my cell phone connection. So like that should be somehow more stable than my modem, my actual modem. That's a wired connection. So I don't know where I cut off, but I'll start from not the very, very beginning. I'm not going to introduce myself. But I think you asked the question.
Yeah, you were about to put something in chat regarding the determination on AlphaFold 2.
Yeah. So not only does AlphaFold seem to be able to predict, this protein has other things associated with it, or like, this protein has, let's say, iron bound to it, or some other metal. Like calcium or magnesium, but it also seems to be able to predict, or at least make some prediction, as to what this protein can bind to. As in the example that I'm going to put into the chat, if you give me a moment, is basically, it's analogous to pretty much the example that I just gave with the antifreeze protein, of like, not only is it able to like solve the structure of the antifreeze protein, of like, it looks like this, and it might, let's say, might predict to some extent the network of water molecules inside of it, inside the core, but also at the same time predict that this is an antifreeze protein, pretty much predicting its actual function, as in like, this is an ice binding protein using that antifreeze protein. As in like, not this is the structure, and actually like this is what it does. So pretty much linking those two things. Just as I sort of like attempted to highlight it earlier, I might have got cut off of like the structure of a protein determines its function. So not only does AlphaFold seem to be able to predict that structural information, but also seems to have some ability to make that leap from the structure to its function. As in like, also able to bind ice. Or in the example that I'm going to give, is it's able to predict that this protein breaks down those PFOAs, those perfluoroalkyl substances, which are like those are the molecules that are accumulating in our environment as a result of like Teflon and all that stuff, and all our packaging stuff, where that's an ever-growing concern. The quote unquote forever chemicals. That how can we stop them from being forever chemicals? And one of the ways that is being explored is through proteins. That just as the proteins, that antifreeze proteins can break down ice or prevent ice formation, there are totally proteins that appear to biodegrade those forever chemicals, and that might be a potential solution. And I'll link that in the chat in a moment. One second. Do-do-do. And that's also holds true, actually. So this isn't AlphaFold specifically, but I think, correct me if I'm wrong, but I think falls under the umbrella of AI, because I think in the paper, let me just check it. So it wasn't AlphaFold, but it was machine learning. And it's in the title of the paper. I can link that in the chat. It was machine learning aided engineering of a protein. So this is another area that, let's say, again, assuming machine learning is under the umbrella of AI, it seems like AI is being pushed in the field of protein engineering, because that's one of the reasons why this is like the overlap, or like the dynamic overlap between, let's say, AlphaFold and determining protein structure. And so if we determine its structure, well, and we know its structure to a high degree of accuracy, well, then maybe we can engineer it, or we can start tinkering around with it to either make it better or to suit some specific purpose. And the paper that I'm going to link in the chat is the one that I just linked. It was about basically the ability to predict that these proteins bind and potentially break down those forever chemicals. Here, machine learning is being used in the context of protein engineering, as in, can we make a protein better? And in the specific case of this publication, it's to make it better for the purposes of breaking down microplastics. Because just as those forever chemicals from, let's say, Teflon are accumulating, I think virtually everyone now knows that there is this issue of microplastics that we currently don't really know what to do with. And one of the ways that's being explored is pretty much using proteins to break them down or to degrade them. Because we actually know, we've known for a while, that pretty much proteins found in nature, they appear to have the ability, if you look hard enough in nature, you can find a protein that will break down virtually anything.
Right.
And this includes plastics, as in it seems like, if I remember correctly, I could be mistaken since it's not my strict area of expertise, but we have found bacteria that produce proteins that break down plastics or certain type of plastics. And they actually do this, it appears, again, if I remember correctly, as part of their metabolism, as in they're basically like breaking it down and eating it or using it as a source of nutrition. And so if that's the case, well, then we might be able to harness that for our own abilities, given the fact that we're littering our environment with a bunch of microplastics. As in, if we know that these bacteria or these microorganisms produce this protein that breaks down plastic, just as we can potentially, or we are using the antifreeze proteins for our own purposes, maybe we can use these proteins isolated from bacteria to break down plastics. But one of the major hurdles is like, these are microorganisms, so they're bacteria. They're small. And so, like, they don't need a lot. They don't need to break down mountains of plastics. And so it's like, well, sure, it can break down plastic, but it's going to do it at such a slow rate that it's not really meaningful. And so one of the ways that, let's say, is being explored is like, okay, can we actually like accelerate it or make the the protein found in nature better? As in, can we actually engineer it? As in, make it more efficient? Or I think one of the other challenges that is trying to be overcome is that the conditions in which these proteins break down microplastics, they're very specific conditions. I think it needs like a specific temperature, either like a higher temperature or lower temperature. I can't remember, but basically, it needs very unique conditions in order for it to carry out its function of breaking down plastic. And this is where the protein engineering is coming into play. I'm like, okay, maybe we can engineer it so that it no longer needs these unique conditions. Because, like, sure, again, who cares if it can break down plastic, but it does it at a snail's pace, and it needs, let's say 50 degrees Celsius for it to carry out its function. I just sort of made that temperature up, but I do know that it needs unique conditions. And so this is basically, can we start tinkering around such that, okay, it functions at room temperature, and it's just like a plastic eating or plastic degrading machine, where we've just like accelerated it using protein engineering principles. And this is one of the aspects in which, again, assuming this is AI, specifically in this paper, they use machine learning specifically, where it's like, go ahead.
Let me answer that question real quick. So when the layperson talks about AI, they are talking about what could be artificial intelligence or machine learning or deep learning. Only in like people who want to get very specific about what you're talking about does some sort of definition between those things come up. Your average person is going to think of machine learning as AI and refer to it as AI, and AI is a very comfortable phrase to say. So there are people who will adamantly defend these definitions, and I think that they are somewhat in the layperson area, they are unnecessary, definitions to like just say that this is this and not that, because one of the issues that comes up with artificial intelligence or what have you is that it's only AI until it works, right? And then then it's defined as something else, right? And it's one of the problems with getting people to discuss AI and talk around these things is because it's no longer AI once it works. It's only AI until that point. And so it's one of those, the differences are not really necessary to discuss them in general. And on my channel, when I say AI, I could be referring to machine learning, I could be referring to deep learning, or I could be referring to artificial intelligence, and getting stuck on which is which and how they differ, I don't think has a decent utility for general discussion. You know what I mean?
Yeah, where I pretty much use AI. So again, I will fully admit I'm not an expert on AI, but I use AI as like a catch-all. That's where it's like pretty much as you outlined of like I understand machine learning and deep learning under the umbrella of AI, and that's why it's like pretty much in my mind, and this might reflect my ignorance. It's like I just use AI of like, well, if it uses an algorithm and it's some sort of iterative process, I think that's like AI enough for me, kind of thing. But I don't know exactly like
It's one of those things where it's only going to matter if you run into somebody who wants to be pedantic or is like really in their space, and they need to define these things as different things. In general speak, you should be able to say AI and just move forward, right? Like it should be that kind of thing.
Yeah, I would hope so. But I know, if I talk about it more, I know, and also, I have my pedantic side myself for sure. So I know I've been guilty of, I'm totally guilty of this at times where, again, as much as I want to, so at the end of the day, I want to make science accessible. And I definitely, ideally, I don't want to get caught up of like, well, machine learning, technically not AI, deep learning, technically not whatever. Even though terminology and jargon is important in science, and
Right.
so that we're all on the same page of what we're talking about. But hopefully, there's some grace given a little bit, especially when trying to hopefully make ideas and concepts accessible to a wider audience.
Right. And for me, like, given my understanding, AI encompasses machine learning. Like, machine learning is part of artificial intelligence. The idea that this is how the thing learns, this is a particular process under which the thing learns. But it's not something that comes up in the same way with like humans. We don't necessarily differentiate between human learning and machine learning, or human learning in a particular kind of thing, unless we are needing to get technical for some particular reason. So generally,
Yeah,
AI covers everything.
that's why it's like, again, I totally have a pedantic side where it's like, I totally understand, if I'm at a conference and, I use the term, and I'm, talking to other people in the field or other scientists, and I misuse the terms like accuracy and precision, which
Mhm.
means something specific in the sciences. But I'm hoping when communicating that I can use something like accuracy and precision somewhat interchangeably,
Right.
and not be burned for it.
So, one of the things that we talked about way back in the long ago was the number of proteins, like the speed at which and the capacity at which new proteins were being like predicted. Um, and I I did not go back and watch because I have so much free time, but
But yeah, I understand.
the number of like 2 million came to my mind. Something, or is it 200,000?
So 200,000 sounds more correct for
Okay.
sure. In terms of like at the time, the number of protein structures actually solved. So to hopefully maybe give a brief review,
Hmm.
it's like, so yeah, there's what we have, a literal a literal protein data bank, as in, generally speaking, when we solve the structure of a protein, which can be actually a pretty, when we actually solve it or when we experimentally determine it, not predict it using an algorithm, but actually, again, actually solving the structure. And this is what it should look like in nature, although there's a little bit of like an asterisk there.
Hmm.
Since it's a noteworthy thing and it can be like pretty laborious, we upload it to the protein data bank for pretty much other researchers to use and to hopefully keep track of the knowledge that we're accumulating. And this protein data bank has been around for a while. Like, it goes back, decades and decades. And so, like, in nature, uh, like, so there's like literally, tens of millions, if not, I don't know, but basically the number of proteins found in nature, like, it's in the tens of millions, if not hundreds of millions, if not more.
Hmm.
But basically, it's on the order of millions, maybe thousands of millions, probably not. But we've been chugging away in science, trying to ideally solve the structure of every protein found in nature, ideally. And we've come up pretty short. We've pretty much, if it's a piece of pie, well, if it's an entire pie, we've caught just a tiny sliver of that pie. Like 1%,
Hmm.
if that. Uh, because, like, yeah, 200,000 sounds about right. Uh, and so I think now, so before, like I said, when we actually solve them using experimental methods, we upload it, and we, usually, or pretty much not usually, always, it's like, here's the publication associated with it, and here is how it was experimentally determined, as in, like, ideally, you would find the recipe or the methodology that they used to solve the structure of this protein before they uploaded it to this protein data bank. I think since then, I'm actually going to check right now. I think since then, there's kind of like a new section where it's like, basically, we now have, as part of the protein data bank, I think, predicted proteins, as in this is what, let's say, AlphaFold is predicting, as opposed to, like, this is the actual solve structure using conventional or more traditional, maybe old school methods. Not that no one's using them now. Like, the AlphaFold has not replaced, boots on the ground solving the structure of a protein. It's still all just, as far as I can tell, prediction at this point. But to actually check, I'm going to check on the website now. I think. So yeah, if you go to, it's rcsb.org. I'll link that in the chat. So like before, if you go back, whatever, 2, 3, 4 years ago, you at the top of the website, they give you pretty much like the running tally of what it is. So yeah, you weren't far off in terms of 200,000. So at the top, so not only do you have now it's at like 205,000. So, approximately 5,000 structures have been solved, experimentally since the last time we spoke. And now there's like this new number underneath, like a million computed structure models. So this is brand new. This was not there, 2, 3, 4 years ago. It was just that number of like probably whatever, 100,000, 150,000. So, well, you can see, that even just comparing, the computed number to, actual number using conventional methods, like the computed number it's 5-fold higher than what's actually determined. As in, it looks like, there's been an exponential increase in pretty much what's been uploaded to the protein data bank, where again, these are predicted, they're not actually solved. But we have, let's say, a fair amount of confidence that probably for a lot of them, the prediction will actually match once we actually go and actually experimentally determine the structures, which is pretty cool, because it just shows kind of like a sort of an exponential leap in our knowledge.
And so, like, how much easier is it to solve it when you have the computer predicted structure? That
is a really good question.
Those are my favorite things people say.
And I probably cannot give the most comprehensive answer, even though kind of like a protein structure and solving protein structures a little bit my expertise, not my strongest. So maybe to give you an idea of how difficult it is to solve a protein structure through conventional methods, as in, like, as part of my PhD research, like I have actually been attempting to solve the structure of a protein, in that if I actually solve it, I would actually be uploading it to this protein data bank. And we would publish the structure. I do actually have a on the topic of AI, pretty much one of the publications that I do have is actually like I quote unquote solve the structure of a protein, or rather I predicted the structure of a protein, but not using AlphaFold. This is pre-AlphaFold. This is using it's computationally, but it's sort of a much more crude method. But yeah, pretty much I've been spending years trying to actually solve the structure of a protein, in the hopes that it's uploaded to this protein data bank. So far, and this might be a reflection of me being a bad scientist, totally possible. But so far, no dice. So like basically, your question of like, okay, once you predict it, does that actually can that facilitate you actually solving it? Does it actually provide helpful information? The answer, hypothetically, and I think in reality, is yes. Where like if you're able to kind of, at least to some degree, accurately predict the structure of a protein, it should give you some insight into how you can actually solve it experimentally, such that you can hopefully make the comparison of like, oh, what I actually solved using conventional methods, does it actually match the prediction? So to give you an example, or like why AlphaFold or a predicted structure can actually potentially, or should hopefully actually help you in solving the actual structure, is so one of the conventional methods used to solve the structure of a protein called X-ray crystallography. That's pretty much the bread and butter of solving a protein structure. So what does X-ray crystallography mean? I think I might have touched on it last time, but I think it's worth going over again. Where it's basically growing crystals, hence the term X-ray crystallography, because you are attempting to grow protein crystals, and that is basically more of an art than a science. As in, like, that is pretty much one of the major hurdles before solving the protein structure is like, can you actually make a crystal of your protein of interest? And what makes a protein crystallize is kind of like you literally kind of like take a carpet bomb approach of like, we'll just try a bunch of things and hopefully it works out. Or rather, we start by using what has been done in the past, as in like, oh, these other researchers, it's basically trying to find optimal conditions of like the right temperature, the right pH, kind of like, I guess the crude term of like Goldilocks. Like pretty much what makes a protein crystallize is like Goldilocks conditions, but you have no idea actually what those conditions are. You have like maybe some guide from like other researchers, but like what worked for one researcher and like the Goldilocks conditions that allowed their protein to crystallize, there is absolutely no guarantee that it'll work for you, because for a multitude of reasons. But you're basically searching for that Goldilocks zone of like, oh, this is just the right conditions to make a crystal out of my protein. And again, this might just be a reflection of me being a bad scientist, but I've been trying to find that I have spent years trying to find that Goldilocks zone for my protein of interest, and so far, no dice. But using AlphaFold, if you're able to beforehand predict the structure of your protein with some, a high degree of accuracy, assuming that, since AlphaFold does appear to have a high degree of accuracy, more or less. There's definitely an asterisk associated with that. That should actually give you an insight into kind of like what would make your protein happy, or what are the conditions of that Goldilocks zone. You won't be able to exactly know, but it should give you a decent hint where it's like, without getting like, or try not to get too technical. But like, as I said, proteins are complex three-dimensional structures. And so, as I highlighted earlier, they have a surface and they have a core. And what would allow or what facilitates a protein turning into a crystal? There's multiple factors, but it's one of the factors is like what its surface kind of like looks like, or what the landscape of the protein looks like. And if you know the landscape, it should help you in finding that Goldilocks zone. And so hopefully, that bears out in actual research. I don't know of any publication, although I haven't done a deep dive. But as of now, I don't know of any publication that has used AlphaFold in that vein of like, oh, we've predicted it, and then through the information gathered by the prediction, we were actually able to carry out the conventional methods to crystallize the protein. But I'm sure if that's not already there as a publication, I'm sure it's like in the pipeline. But I'm pretty sure if I just dig deep enough, that publication is there.
Yeah, there. Like I just did a quick Google, because I was wondering the same thing. Is like if there's a known quantity, like the crystallization of proteins, is there a way for AI to simulate that in a way that provides advantage?
Okay.
And it looks like a lot of that stuff is from a year ago, but there are some articles from just this last month.
Yeah. So actually, I should have thought of this earlier. So yeah, you are no surprise correct. Where so yeah, when I say protein crystals, again, without getting too technical, like what does that mean? Or like what drives a protein to turn into a crystal? What drives a protein to turn into a crystal is is protein interactions, as in proteins interacting with other proteins. Because that's literally, I mean, in crystallizing a protein, what you're actually doing in reality is you're going from your protein in liquid, and you're trying to get it into the solid phase, as in to turn it into a solid crystal. So ultimately, whatever, to use crude terminology, you're trying to increase the density of your protein. You know, so dense that it turns into a physical crystal. As in, like again, if you look at you can look at these things with a light microscope, and they are actual crystals. But they start off in liquid solution, as in they start off as like actual droplets, and then through hopefully finding that Goldilocks zone, they start forming crystals, as in increasing in density. And what drives that formation is protein interactions, as in the proteins interacting and sticking together to form the crystal. And totally, that's actually one of the things that I want to cover, is like AI in predicting protein interactions. Maybe not AlphaFold specifically, but this is where it's like I don't think it was it was either like machine learning or deep learning, right. Where it's like let me see if I can get it up. It was, I can't remember. Yeah, so they call it a deep learning framework. So I think that falls, based off what you outlined earlier, I think that falls under the category of AI.
Right.
And so, and I'll link this in the chat in a moment. But like, yeah, totally, AI is being used. So not only, as I think I highlighted earlier, not only in trying to predict the structure of a protein, but also trying to predict, again, what those proteins interact with. And so, totally, if you're able to predict what drives a protein interaction, and you're actually able to accurately predict what drives a protein interaction, then totally that should help in actually forming that crystal. Because at the end of the day, what forms that crystal is literally the proteins coming together and interacting with each other such that they form a crystal. Totally.
So, and this is one of the aspects for like I think like a large language model within the science community by discipline, right? Like, because there's the feedback loop of artificial intelligence, where artificial intelligence makes more discoveries possible faster, and there's just so much data and so many, so many experiments, so many papers, all these things that you as an individual, I mean, you have a job, you have a life, you stream on Twitch. You couldn't read them all,
The life part is questionable, but I take your point.
So having the ability to like, we're just gonna like scan this into the large language model, and then I can query it directly in, I can ask it direct questions as opposed to attempting to, sift through all these papers and everything else. And I see that as like a tremendous advantage to research going forward. What would be your opinion?
Totally. My opinion is I totally agree with you. That it'll presumably dramatically increase our productivity. And as you say, it's I have no problem admitting it's very difficult to stay on top of all the research that's coming out and all the research that's relevant to your own particular research, but relevant to the field at large, relevant to the general public,
Mm-hmm.
and what's relevant to society at large. I totally can sometimes get overwhelmed. Maybe not overwhelmed, but like there's so much research that I want to go over and consume, but I just don't have the time. Where it's like to sit down and like dissect a paper and really truly understand it, if in fact you can. At least for me, that's like a significant time investment.
Sure.
Definitely for some papers that are like right up my area of expertise. It's not hours and hours. But if it's one like even the ones that I linked in chat, which is like those are totally biochemistry papers. But they're biochemistry with some computational chemistry, where it's multidisciplinary. So it's like even those papers, like if I really want to understand them or have like an in-depth understanding of them, it takes time. And totally, if as you say, those language. How did you term the language models? Are pretty much
Large language model.
Yeah, the large language model. Yeah. Where it's like if it's able to summarize like a paper for you, or like if the large language model is like keeping track of like the state of research, and I just use it as a consultant, so to speak, to like guide my research. I totally see a use for that. I have some concerns for that, whether it's actually like a good thing. But I totally see it as like it has the potential to really accelerate. Where even just using the example of like that protein data bank of like already in like less than a year, the predicted structures of proteins dramatically outnumbers like what we've actually solved with conventional methods, and this goes back like decades, as in like the even if just like 50% of the predicted structures are actually like correct, like already that's 500,000, and like that 500,000 already exceeds like the decades that we've taken to solve 200,000, right? So like that's a huge leap or acceleration in productivity. We're pretty much now trying to play catch up, as in like we have these like roughly 1 million predicted structures. Now it's like, okay, do the confirmation, as in does what's predicted actually match reality? So already like we're sort of like behind in terms of like what AI is generating, or we're trying to play catch up. And so I can totally see, as you outlined, I might be consulting one of these large language models to maybe assess the current state of research, or like get a summary, or simply like ask it a question, and it like guides my research. I totally see a use for that. Whether it's a good thing or not, I guess separate question. But like totally, I see a huge potential for accelerating or increasing the productivity for sure.
What you mentioned concerns. What kind of concerns do you think you have?
Yeah. whether they're actually, real concerns or whether they'll actually happen, I do have a concern of, let's say, I might just be too old school, where I have a concern of, kind of like offloading or outsourcing knowledge where, as of now, and again, I might just be going about it the wrong way, but as of now, I keep track of, let's say, the state of research relevant to, me, through what's, contained in my brain, or what's left of my brain. And I have like a reference manager that, if anyone comes across my stream, I have like my own database of papers that I keep track of, and I highlight things. But generally speaking, what's highlighted and what's extracted from research that I cover, like it's in my, my brain, or again, what's left of it. I do have some concerns of like, well, some of that knowledge is just going to be offloaded. People will be, again, I might just be too old school, of like people just like, just as I will fully admit this, do people still use paper maps these days? Can anybody read a map? I like to think I can, but now we just rely on our phones and GPS and just like turn left, turn right, and just the directions there. But I think there's something to be said of like the ability to like read a map or have that knowledge, and I think there's something to be said for like hopefully a scientist having the concepts, having important concepts, in them. They understand them, as opposed to like, well, just basically my concern is like people be too reliant on these things. But that if AI, or I guess if we get to the point of like AGI, whatever that means, like actual, I don't know, close to or actually human intelligence, but whatever, in a computer, I guess that's not inherently a bad thing. But one of my concerns is like, yeah, we'll just be too reliant on it, just as I think we are sometimes too reliant, and I'm guilty of this, too reliant on our cell phones. Like, I probably have lost the ability to read a map. I like to think if I really need to, I can. But just as, again, I might be too old. Does anybody still write cursive? I appreciate the fact that I can still write cursive, but I recognize that that's a useless skill these days.
Right.
That's one of my concerns.
They really, like, when I look at things like reading a map, and let's call them, I guess, artifacts of an earlier time, is because I can read a map on like multiple levels. I was a Boy Scout, some military training, this kind of thing. So I can read a map, but under what conditions would I have to be in order for that skill to be necessary? And what is the state of the world around me? Like, yeah. I could end up in a situation where like I'm outside of cell phone range and everything else, but if I'm in that condition, I'm probably on a highway. So I'm going one way down the highway or the other way down the highway, So I don't want to downplay anyone's concerns about over-reliance on technology. I just do want people to appreciate under what conditions would that over-reliance on technology negatively impact you. You know what I mean?
Oh yeah, 100. Like I said, using the example of, I recognize writing cursive is a useless skill. I'm like, what state of the world are we going to be in if we have to go back to cursive? I don't know if I want to live in that world, right?
Exactly.
As much as I appreciate, cursive and calligraphy, where it's like, yeah, there's totally something to be said for what you just outlined of like, if we're really going back to maps, well, then, we've really gone off the rails, I guess.
Right.
Just as if we go back to cursive, we probably also gone off the rails. But another one of my, so this probably just reflects my ignorance of, let's say, these large language models and things like ChatGPT. Like I'll also fully admit, I I've not really used ChatGPT all that much,
Mhm.
even though like I totally could. I just use it kind of as a fancier Google, even though I
Mhm.
know it's way more has its potentials way more than that. Um, but at least so far, I have been able to intentionally trick it, or like at least given where I understand it's an ongoing process of making it better. So I have no doubt that we'll probably get to a place that this will not happen. Um, but so far, I have been able to like ask you questions that like yeah, it does give an answer, and it's technically not a wrong answer, but it's not the I would say not the correct answer or the most comprehensive.
Mhm.
Um, where it's like something is absolutely missing, um, and again, I understand that this will probably is an unfounded concern, or rather will be addressed in whatever the future of Chat GPT. But yeah, my concern is like yeah, there will be some sort of again, we'll be so reliant that a blind spot or the fact that it's lacking something, we won't know it or recognize it, so to speak.
Yeah.
And if that's guiding research, or if someone is using that primarily to guide their research, I can see some potential pitfalls. But there's the opposite coin as well of like if someone is actually informed enough, like it's just you can totally use it as like it has a lot of potential in like yeah, accelerating research. I recognize that.
And that's, in my opinion, that's not an unfounded concern, because the accuracy of the information that you're dealing with, especially on your level, is important, right? Like if the information is incorrect, then you're not going to be able to crystallize the protein or anything else like that. So there there's already been a recent, let's call it an upgrade to the process, where ChatGPT is now working with various plugins where it will go out to the plugin to get the information. There was recently a lawyer got themselves in trouble because they used ChatGPT to write up the legal brief, and it referenced cases that didn't exist. And then yesterday on stream, we watched a video where these plugins connect to various already online legal websites, and it's able to draw the information from there. So that, I think, is an important aspect, is the idea of an external verification to check whether or not the information that you're being given as the user is accurate, in that way. And
Yeah,
I feel like it is being addressed, but at the same time, I completely understand the concern because of the previously stated reasons.
yeah, that's pretty much what I use. Of the very little that I use it, I'm pretty much use it as a double checking tool, or even just like not even just a double checking tool for let's say research, but a double checking tool of like my own my own memory and my own brain of like, oh, do I actually remember this like accurately? Do I
Mm-hmm.
still understand this concept? But also at the same time, I'm relying on ChatGPT to give me like the right answer.
Mm-hmm.
Um, and I am putting some faith in it of like, oh, what I have in my brain is actually correct, assuming ChatGPT is correct. And yeah, of the little that I used, I actually used it most um, without giving anyone's name away, but a fellow content creator, a fellow pretty large content creator, they asked me to come up with some questions to so they were engaging with someone that was claiming to hold a PhD in a certain field,
Mm-hmm.
specifically I think genetics. And they asked me like, hey, can you come up with some questions that will basically like vet this person, as in like if they're able to answer these questions, they likely do have maybe not confirm they have a PhD, but they have some in-depth knowledge of genetics.
Mm-hmm.
And then the strategy that I used was like basically, can I stump both Google and ChatGPT? And it totally took me I was impressed with how difficult it was to fool ChatGPT, or rather to come up with questions that ChatGPT wasn't really answering. I spent a good actually 2-3 hours coming up with just like 4 questions where it's like, yeah, Google, not only will Google not give you an answer, but ChatGPT, it'll give you an answer, but it's not going to be let's say the most correct or like a robust answer. And that is where pretty much some of my concern, but again, I know that this is just like early iterations.
Right.
So it's like I'm sure my concerns are unfounded, and I'm just too old school.
Well, I want to say that unfounded, I think, is too strong a word and really downplays the. There used to be a word, a term that got tossed around a lot in the 80s, which was techno shock, right? And I don't hear that as much anymore, but I think it's even more applicable now as technology is on this double exponential, curve. So I would never say unfounded. I would just like I think one of the concerns that people have is they look at the thing and they compare the technology, the brand new technology, with like the cell phone. And the cell phone is a proven technology and they've had it for some time and they're comfortable with it and it works, generally speaking, all the time and like that. And ChatGPT doesn't hit that mark necessarily, and a bunch of these other technologies don't. But we have this expectation that it should be perfect or get the fuck out. And that is not the case, right? Like you indicate, there are growing pains. We are getting access to this maybe sooner than we should, but our use of it is going to help improve it in the future, which is why I advocate everyone to make use of these things.
Yeah. And what I would say is, again, I know, like as you said, we probably have gotten access to it sooner than we should have, and no doubt these companies such as OpenAI, they're using what they're getting from us to make it better. Mm-hmm. So I have no doubt that it'll probably be way more refined, and as you say, it'll probably just become like a cell phone, where not that the cell phone is perfect, but like it's highly refined, and the cell phone doesn't just that the GPS very rarely like goes off the rails, but it does happen, but that's like the exceptional exception.
Right.
But yeah, I was let's say, once I clued in, so basically when I was trying to stump ChatGPT and come up with like these questions, like it took me like 2-3 hours to like come up with the first question, but once I figured out how to like stump ChatGPT, or like what I needed to leave out such that ChatGPT gave an incomprehensible answer, like it didn't take me that long to come up with the other like 3 questions for this content creator, where it's like, I have no doubt this has changed since then, but like once I realized what like sort of had some idea of what ChatGPT was doing, or like what it was latching onto in my questions to generate the answers, I was like, okay, I know that for this next question, I know that I just need to leave this out, and ChatGPT like goes off the rails. And so actually, I guess, again, I'm sure this will be addressed, or if not already, but like, yeah, as far as I can tell, it seems to matter how you ask the question to ChatGPT. Yeah. And so it's like, I'm just as it matters how you do your Google search and the results that you get. I guess it's going to be become an acquired, just as Googling is an acquired skill. I'm sure engaging with these something like ChatGPT and whatever its competitors is going to be an acquired skill. Where it's like, like it was literally like when I was making these questions, it was like I just removed like one word or like 1 or 2 keywords, and the question is totally still comprehensible, as in like it can be read to be read to a person, and like an actual geneticist should be able to answer it. But ChatGPT like was not, or rather like the answer was not really like all that comprehensible, or it was like it's like the most surface level, like ambiguous answer. And so like once I clued in of like, oh, like it really matters what you include in the question, then it became much easier to come up with additional questions to stump it. And so like, yeah, if a researcher, I guess another concern would be like if a researcher is not trained in how to ask the appropriate question, they might be getting, just basically, garbage in, garbage out, right? So I see that as, I guess, another area of potential concern, potentially.
Yeah, and like I can definitely, I will throw you a link to one of the YouTube channels that we watch on stream, and like it a lot of their content is related to getting more accurate answers out of ChatGPT. So I think it might be of use to you. So I'll throw you that.
I would love that. Yeah.
After stream. But interesting because you brought up another content creator and based on like if I can extrapolate from the things that you said, I'm going to say that this is in the, if not debate space, the aggressive conversational space, adversarial conversational space. And one of the games in that space is, like how fast can you Google something if you're challenged on something you don't know. And ChatGPT has the potential to be a game changer in that space because it'll provide you with a response rather than the information that you have to digest first.
Oh yeah, 100%. So there's to answer sort of your question, or to like expand upon, the content creator and how I was somewhat tasked with, coming up with some vetting questions. It was you hit the nail on the head. It was sort of in the debate sphere, where it's like no surprise. This person claiming to be a geneticist were making some pretty questionable claims, really questionable, borderline, bigoted, racist claims.
Okay.
And standing on, their credentials that these are true statements. So yeah, this content creator saying, well, I don't think that they have a PhD in genetics. And so, in the debate sphere, and I was really, in the end, I was really happy with myself coming up with these questions because, it took some time, and might just be some false pride, but it was like, you can actually, these questions are usable, and at least at the time, ChatGPT did not give the correct answers. But also, to your point, when ChatGPT was, I think, first released for the general public use, someone was using it on a debate panel. They were memeing, but they were pretty much like this person who I've been on multiple debate panels with. I know like their manner of speaking, and I know more or less like what their positions are and sort of like how they speak and make their arguments. But then like for this particular debate panel, like towards the end, there was a notable like switch. They maybe sound, not to insult or denigrate him, but there was like a sort of an uptick in sophistication, so to speak. They were sort of like memeing, but they did reveal, to no surprise, they were using ChatGPT towards the end, and they were just like reading it. But like it did take not only me and the other panelists a little bit to like clue in of like, what they're saying, what they were saying, what they were reading from ChatGPT. Like it was comprehensible. Like and they were arguments pertinent to what was taking place on the panel. We pretty much like only, or at least generally speaking, we only noticed just because like there was a marked shift in basically like their mannerisms or like the words that they're using. Where like this doesn't sound like something that this person they wouldn't use a word. I don't even think they know what this word means, so
Right.
to speak. So like they were able to fool us for a bit, and I agree with you. Hopefully, might be a little bit of a bizarre world where it's just Chat GPT debating each other on a panel. But I can see some also potential uses of like, hey, if someone's just spouting BS, I'm hoping ChatGPT catches that,
Mhm.
and that can be used on a panel.
It's actually one of the proposed like future uses of artificial or general artificial intelligence is what we say around here, but most people say artificial general intelligence. Is not one, but like a cluster of them having those kind of debates with each other, like so, which would there even with the alleged potential infallibility of an artificial intelligence having like going back to the Romans, you had the triumvirate, right? Like, so you
Hmm.
had three people that had to work together. Having multiple AIs that have to come to some kind of consensus, I think, is um, is an aspect of like AI safety where it would prevent the ones that were doing something that might not be in our human best interest from doing those things because of the others not being able to reach a either an agreement or a consensus or what have you. So
Yeah.
you might see that kind of thing in the future.
No, so that is also another like concern of mine. I have so many concerns with these technologies. Some actually relevant to science, and also like outside, like I also have like social concerns.
Sure.
Where I've brought this up of like yeah, I also know people. Well, I'm sure there's way more people now, but like they're using ChatGPT to like to compose emails,
Mhm.
right? Just like I just want to send like this is the message or like this is the idea that I want to convey, and then go ChatGPT and hit send.
Mhm.
And I also know that people are using ChatGPT, to like compose like text messages. And whether this is a valid concern or not, I don't know. But it seems a little bit silly if we get to the point of like just two people using their cell phones and they're interfacing through ChatGPT. Of like, well, this is what I want to send as a message. ChatGPT types it out, and then this person receives it, and they have like you just have ChatGPT interfacing with each other. I
Right.
guess like ideas are getting conveyed, which I guess maybe that's what ultimately matters. But I do see it seems a little bit strange to me, and also what you brought up in terms of like the debate space, and let's say competing, um, well, these competing chat GPTs. I do have a concern whether valid or not of like just as we have Wikipedia,
Mhm.
which I think is great. I use Wikipedia all the time since like it's since it first like hit the internet, uh, and like as it went through all the growing pains. But I am concerned, just as like the one of the competitors to Wikipedia is Conservapedia. I think there's already like accusations that like ChatGPT has like whatever a left-leaning bias,
Right.
or like ChatGPT is like woke. I am concerned of like a competing Conserva GPT or something like that.
Uh,
Um,
it's called Chaos GPT, and it already
yeah,
exists.
yeah. So that none of this surprises me. And so it's like as much as I can, let's say, see some, be some signs of optimism, where it's like, oh, if there's so much misinformation and disinformation, let's say, well, not on just the internet at large, but in let's say the debate spaces that I occasionally run in, maybe these large language models can clean that up, but then yeah, it's not going to be cleaned up if you just have a competing large language model that like it might be designed to come up with misinformation, disinformation to combat the actual real information. And so I can see that, like, I can see it both, making a debate space better, if that's even possible, or just like muddying it even more.
Mm-hmm. Yeah, in with the the what you said about two people communicating back and forth via like a chat GPT text kind of thing, and they're both talking through chat GPT. Um and kind of to draw on the debate space is how people will say something that doesn't necessarily convey the intent of what they were trying to communicate, and also people will jump on something that's not properly formatted in that regard in order, um either, from their point of view, they're either misinterpreting what was said genuinely, or they're misinterpreting what was said, to fuel that machine. And there's something to be said for an interpreter that would allow us to speak to each other in a less, adversarial way, kind of thing. And I think one of the issues we run into, like with social media and Twitter and all these things, is that um, there's like when I log on to Twitter, certain switches get flicked in the brain that make me perceive things in a way that might not be intended by the sender. You know what I mean? And something like a chat GPT type additional chatbot could render some of that, like, maybe less, at least.
Yeah, 100%. That's I totally agree with you. Where I see a utility in, like, I mean, this is something well, I've known all along, but I've come face to face with it in my dabbling of the debate sphere,
Mhm.
of, like, your rhetoric matters. Of, like, you could have the best idea, you could have the best argument, but if you can't formulate it, or rather, if you can't formulate it such that the other party actually receives what you're trying to send, it's irrelevant. Um, and so, totally, I can see a utility, or like a strong use for something like this. Like, hey, if something like ChatGPT is in the best position to, let's say, uh, distill your argument, or actually formulate your argument and actually put it into words that the receiver will actually receive. There is great utility and power in that, where it's like, I will fully admit, um, the reality is, it seems like rhetoric matters, at least, again, in the mild debating that I do.
Mhm.
And I will fully admit that I am not the best rhetorician, if not maybe one of the worst rhetoricians, arguably. And so it's like, again, the arguments and the ideas, sadly, sometimes appear to have much less weight than how you deliver it. And so, like, yeah, if ChatGPT is just better able to deliver it, especially like on Twitter, which I agree with you there. You log on to Twitter, and it's like, yeah, there's a whole bunch of buttons being pressed, which is why, like, I just minimally engage, or only engage with the people that actually matter
Right.
to me. Because it's like, yeah, if ChatGPT can clean up a space like that, well, then I guess that's a testament to the power of ChatGPT.
And as Goku in my chat pointed out, is like I can. What immediately popped to mind is a debate panel, in which no one can communicate directly. They have to type their thing into Chat GPT and read whatever Chat GPT says, and that I feel like it would promote accuracy and less vitriol, but like they pointed out, is like, would it be entertaining? And I don't know, like maybe the first time it might be, but the longer that kind of thing went on, I don't think that the people who tune into debate panels would want to see that.
Yeah, that is, again, that speaks to a lot of things. I think that would be First, I think that would be a super cool experiment to run, and I almost want to, of what little connections I have in the debate sphere, I would want to I would want to run that experiment, or at least try to see if I can get someone to run that experiment of like, hey, let's just try out a panel and we just all just interface through ChatGPT of like it's just the best ChatGPT wins.
Right.
And it's like to your point, or the point that was made by the person in chat, it's like, again, going back to what I said earlier, where it's not necessarily the ideas or the argument, but it's like, yeah, the rhetoric and the entertainment value of like it doesn't seem to matter if people aren't being entertained by it, where it's like, yeah, that type of debate panel where people are just reading chat GPT prompts or prompts from the questions that they ask, that might be, potentially like the most informative, the most strongest argument wise when it comes to a debate, and yet it won't matter, or rather I can see it not mattering potentially if there's no entertainment value, and like no one tunes into it.
Right.
And that's something that I definitely struggle with, where it's like, I have no problem admitting that I am not the most entertaining streamer, and that really I just go by, information, and I try to cover things that are interesting to me, that I'm passionate about. If someone wants to tune in, great. But I knew this before I started streaming, but I come face to face with it of like entertainment value seems to really matter a lot, or rather, well, it matters a lot if you're trying to gain viewership, but I'm not really trying all that much to gain viewership, and so I don't really, I don't go for entertainment, basically. I think that's clear.
And I think it like just spitballing and playing with the idea. I think that would be something that someone like me would have to set up, where they're not as concerned about like constant viewer numbers and everything else, where they're concerned with running an experiment like that. So I don't know, I might hit you up to join the ChatGPT debate.
I would be honored. I would like, yeah, if you I'm there if or when, no pressure, but like if you would be willing to do that, like, yeah, I would love that, for sure, because I think that would be great.
Yeah, let me look into it. So we've been on for almost 2 hours. Is there anything else you wanted to hit on before I let you go?
Off the top of my head, I think I covered most of the highlights. I can talk for hours on these things, but I should probably play it safe and not do that. Where it's like, yeah. So I guess pretty much like to your point, just in like the 5 months since we or roughly 5 or 6 months since we last spoke, it seems like pretty much AI in relationship to biochemistry like has actually taken in that short amount of time like pretty big leaps or steps, where I think last time we spoke, the running counter on that protein databank website like was not there. Like I think literally that was like added like in the past few months, and so like that is a new development where we now have an ever-growing database of predicted protein structures, and it seems like AlphaFold, in addition to its ability to predict just the protein structure, the 3D protein structure of the amino acid sequence and how their conformation, it also appears to fill in all the other stuff that is critical to protein function. Like I said, the example of iron and hemoglobin, it seems like AlphaFold has some power, if not a lot of power, to do that. And on the broader topic of AI, it seems like, ever more, or the power of AI is expanding further and further, where its predictive power appears to be like infinite. Of like my area of expertise is like protein interactions, and it's like pretty much I'm trying to, at an experimental level, in E. coli specifically, as in I'm trying to literally map out a protein interaction network in E. coli, a specific pathway in E. coli, and pretty much answer the question of like, hey, does this protein interact with this other protein? And like I've been spending a lot of time in that, and that is pretty much like the bulk of my research, and yet there's ever more publications showing the power of AI. Like, hey, an algorithm seems to be able to just predict this potentially better than you at some point. Where it's like I'm pretty much like asking the question, like, does protein A interact with protein B? And I'm spending like months to years trying to answer that question, trying to confirm that question. I might just be able to just ask the question to an algorithm, and it might be able to spit out like an accurate answer to that.
Mm-hmm.
That is super cool, and I'll leave it at that for now.
Yeah, no, I'm sure we'll be talking again, especially as I run into things, I'm going to be hitting you up. You and Greg and Homozygote and a bunch of others are like my science avengers, right? Like, I can call on you and say, like, does this sound legit or is this horseshit? Is it real or is it bullshit? And you all have been like more than happy to talk to just some jackass on the internet, and I appreciate.
Don't sell yourself short. No. If you're a jackass, that I don't know what word to use for me then, because.
So why don't you give yourself your outro, and I'll talk to you soon.
Well, first of all, thank you for having me, and also sorry for the tech difficulties. I'm trying to get them solved as quickly as possible because it's super frustrating. It's making me very hesitant to stream my own content because it just cuts out. But hopefully by next week, I have that solved, and hopefully any future conversation we have is not interrupted by those persistent tech issues, which I deeply apologize for. And thank you for your patience. But yeah, this was a super enjoyable conversation, as any conversation with you it always is. You can find me on Twitch, twitch.tv CoreyCampbell84. I'm a biochemist, PhD candidate in biochemistry. I cover science, research, news, and some politics. I pretty much, it's not restricted only to biochemistry, where it's like I'm trying to attempt to collaborate more and more with other researchers in other disciplines to hopefully expand my horizons of the research that I cover. But yeah, you can find my Twitch, twitch.tv CoreyCampbell84, and on Twitter and Instagram, it's Corey Campbell. Thank you so much. Super appreciate it.
Always a pleasure, my friend. Take care. I'll see you soon.
Take care. Be well.
All right, chat. I hope that was everything that you had hoped. I hope that it was informative and entertaining. And, make sure that y'all are in the Discord. It is the best way to, communicate. If there's someone that you think that I should talk to around AI, you can hit me up there. And if there are questions that you think should be asked or anything else like that, like, I'm available to you. I feel my role here is, both to act as your avatar, to communicate the ideas and questions that you might have, or to seek out the information on your behalf and like provide you with the context and commentary on the information as it comes up. AI is happening fast. There is something new every day, and I enjoy what I do, and I hope that you do as well. Again, if this is your first time here, make sure you hit that follow button. And that's about it. I think we're gonna raid a difficult truth. If Difficult truth. Difficult Truth does the news. They are a homie. I really enjoy their content, and if you like my content, I think you will enjoy theirs as well. It's kind of similar vibes. I will be back tomorrow. I'm going to check with Arun and make sure they feel up to doing our stream. If not, I will be back with AI content. If we do our normal stream, then it'll be Indian and South Asian politics. Arun has been just having a hell of a time lately. The Mully Vaikal stream was excellent and informative and professional as hell, and his video with FD Signifier is up on his YouTube. If you don't have the link to his YouTube, it's in the Discord under the Indian South Asian politics section. So either way, I will see you tomorrow no matter what. In the meantime, eat some food, drink your water, take your meds if you forgot. Chuggy loves you. So do I.